R that gives a maximum power. In this particular setup, I don't have to determine the function. I don't have to think in those terms because I already have the function. All I have to do is find its derivative. So then P prime of R equals top function prime is 1 times the denominator minus the top times the denominator prime 2 times R plus R times the inner function prime, which is 1, over R plus R to the 4th power. Like I always do, I keep the constant if it's a factor. But if it's e squared plus R, I cannot do that. But when it's a factor, you can stay patiently. Do not simplify yet. We factor out an R plus R and then simplify. So e squared big R plus small r. And yes, we will be able to simplify in a moment. Okay, so from 2 of those, I took 1 out. So I still have an R plus R. And this is completely out, so I have minus 2R. So the expression is R squared minus R plus R over R plus R to the 3rd power. This will never be undefined because the function will be undefined. So, but it could be 0, which means the numerator can be 0. This is a constant, it's fixed. It doesn't make any difference. So R must equal R for a maximum power, but I haven't shown that yet. And you cannot trust me before I show you. So I create the table in which I have uppercase R because that's the variable, and P prime of R, and I have R and I have 0 and no, of course not infinity, but you know what I mean, 0 here. So this is the first derivative, and I want to plug in for R, I want to plug in 0. I'm sorry, for R I want to plug in 0. So I have 0 here and 0 here. So R over R cubed, this is positive, so this is positive. Let's see on the other side, like for example 2R. I'm going to plug in 2R. R becomes 2R now, which is definitely to the right hand side of R. So this is positive, but negative 2R plus R will be negative R, so that will be negative. And this is typical for a maximum. So now I know that whenever R is the internal resistance, lowercase r in ohms, the power will be maximum. You understand it? Without this analysis, we cannot conclude that R equals R gives a maximum power. That analysis is mandatory. Any questions? And we can get really very sophisticated with these problems. Any questions, please, before we choose another? Okay, let's look at the problem with the cost. A rectangular storage container with an open top is to have a volume of the volume is 10 cubic meters. The length of its base is twice the width. The length of the base is twice the width. If I call this x, then this will be twice x. The length of the base is twice the width. Material for the base costs $10 per square meter. Material for the sides costs $6 per square meter. Find the cost of materials for the cheapest such container. This is our question. So the question here is, find the length, the width, and the height of this box. It has an open top, it doesn't have a lid, so that we minimize the cost. We always try to minimize costs in manufacturing anything. Good. So I need a function. I need a function that gives the cost of producing this box. Okay, so let's start. Cost will be C. I will make it C of X. I can do that from the very beginning. Let's do that by setting 10 equals to area of the base 2x times x 2x squared times the height, and from here get the height to be 10 over 2x squared, or 5 over x squared. Okay, so now let's start with the area of the base, which is 2x times x squared. So this is 2x squared, multiplied by the cost per square meter, which is 10. This is the cost of the base, cost for the base, plus. I have two sides that are identical. Base times height, 2x times height is 2xh, but times 2, 4x times h, which is 5 over x squared, multiplied by the cost per square foot. Plus, we have two sides that are identical, x times h, but times 2. So it's 2x times the height, 5 over x squared, and also times 6, which is the cost per square meter for the side. This is the function. It looks awful right now, but we will simplify it as much as we can. And from this moment on, everything is clear. I have to find the derivative, the critical numbers, and study the sign of the derivative to make sure that it gives whatever it gives, if it's a maximum or a minimum. I don't know. I have to show. No matter what I conclude, I still have to show. Okay, so let's clean it up. So this is 20x squared plus 4 times 5 is 20, 20 times 6 is 120 over x. 2 times 5 is 10, plus 6 times 6 is 60, so plus 60 over x. It cleans up quite nicely. Stop me if you have questions, please. So the cost of function of x is 20x squared, and these have the same denominator, so it's plus 180 over x. Not too bad. So C prime will be 40x minus, don't forget 1 over x, 180 over x squared. I need to find the LCD, and I need to multiply the first one by what it does not have, which is x squared. So 40x cubed minus 180. This function is never undefined. It is undefined at 0, but so is the function, so it doesn't matter. No critical numbers coming from that, but C prime of x could be 0, which means 40 x to the third equals 180, or x to the third equals 9/2. I don't really care for 4.5, but it is what it is. So if I approximate that, oops. Of course, the cube root. So let's see what we get. 4.5 power 1 divided by 3. 1.651. And the measurement unit was meters. Okay, now I need to find h, and that is 5 divided by x squared, which will be 5 divided by the previous answer squared, 1.834 meters. Not sufficient, not at all. I have to show that 1.651, of course it's not infinity, you know what I mean, gives a minimum. I don't know. Let's take a look. The numerator doesn't bother me at all. It's always positive. I'm not going to even waste my time. So when I plug a number to the left, I get negative. When I plug a number to the right, like 10, obviously I get positive. That is good enough for me. I check my work. This must be a minimum. If I'm asked to determine it, then I will plug in the cost function and function at the top. If I'm asked to find what is the cost, then I will plug in C of 1.651. And let's see if I can do it quickly. 20 multiplied by 1.651 squared, and then plus 180 divided 1.651. Did I put everything correctly? Yes, I think so. 163.54 per container in a given situation. Any questions? Any questions? I know we have roughly about half an hour left. What would you like to do? Would you like to look at another optimization problem?
Yeah, can you do one more optimization problem?
Of course. Okay, so this one caught my eye. A piece of wire 10 meters long is cut into 2 pieces. One piece is bent into a square and the other one into an equilateral triangle. Equilateral triangle. How should the wire be cut so that the total area enclosed is a maximum and then a minimum? Okay. So let's take a look. We have 10 meters. And they're telling us that we're going to cut this into 2 pieces. This is one, and this is the other. Let's suppose we're bending this one into a square. So this is x, and this is y. I'm going to immediately write the 10 must be x plus y. And if I bend this into a square, the side of the square must be x over 4. If I bend this one into equilateral triangle, this is y, this is y, this is y, divided by 3. Okay, they are asking us how should the wire be cut so that the total area enclosed max and total area min. So let me put this away. Here it's so heavy. Ah. Okay, so this question is really asking us to find x and y in two different situations. When the total area is a maximum and when the total area is a minimum. Okay, so if I don't have the total area, I will not be able to find anything. So that's my first concern, writing the area of a square plus the area of an equilateral triangle. So now, let's first talk about this first, because that area I'm sure everyone remembers is x over 4 squared. But how do I determine the area of an equilateral triangle? So let's talk about that first. So in an equilateral triangle with all sides equal, we also know that each angle is pi over 3. So the area of this triangle, there are different ways, but the area of such a triangle can be determined with this times sine pi over 3 over 2. So if I'm given two sides in any triangle, but two adjacent sides, and the angle in between, I can write a times b, where this is a and this is b, times sine alpha, this is alpha, divided by 2. There are other ways here, but that's the easiest, I think. Sine of pi over 3 will be the square root of 3 over 2. A is y over 3, b is y over 3. So the area of this triangle, specific triangle, will be y over 3 times y over 3 times sine pi over 3, everything divided by 2. So it will end up being y squared, the square root of 3 over 2, everything over 18. So y squared, 3 times 3 is 9, multiplied by 2 is 18, and this will end up being y squared, the square root of 3 over 36. So I needed to calculate this with you on the side so we understand where we're coming from. So y over 3 times y over 3 times sine pi over 3, which is the square root of 3 over 2. So this is y squared over 9 times 2, 18, times 2, 36. So now we can start. So the total area total is x over 4, everything squared, base times height squared, base times height or the side squared, plus this, which is y squared, the square root of 3 over 36. I'm having a little bit of a problem because I have two variables. Not a problem though, because I know this. So from here, I will write that y equals 10 minus x. So now I can say the total area is a function of x alone. X squared over 16 plus 10 minus x squared, the square root of 3 over 36. I cannot simplify this too much, so I'm not going to bother. I'm just going to go directly to the first derivative. Any questions about the way we determined the total area? Anyone? Give me a second to get some sip of water.